Hello. As Raul said, my name is Matt, and I'm an Android developer at 7Shift, so a little bit of a different world. Didn't understand any of the syntax in the previous two talks, but I'm pushing through it. Okay, so this is a talk about duplication, and I took a note at the end of Alex's talk because he mentioned not being afraid to split code, and I think the topic got a little bit heated in the questions. Before I go into my talk, I think dry kind of errs in the realm of code separation, but this talk is really more about not separating code, but sharing code responsibly. But I do think that in terms of how we should separate our code, what benefits can come from strong code arrangement, will be deeply discussed at the architecture talks in April. So if you would love to come back for that, I think that would be great. And this isn't even the title of my talk, it's my autobiography. Okay, so this is a talk about code duplication, but more specifically, it's about the idea of perceived duplication. So we all know that DRY stands for don't repeat yourself, but I'm going to delve into what that really means, because as developers, it's our duty. We're bound to eliminate all duplication in code. Got some head shakes. Okay, you're on my side. That's good. But I find that like asking around for what people think dry means, it's up to a little bit of interpretation. And I think the true definition gets left in the dust a little bit. So this talk is about the misuse of dry, not so much how to execute dry. So I think sometimes when we learn something, we try and do what we think is good before we actually really know what good means or what good is. And we should question that when we do something like that, are we always doing ourselves good or doing ourselves a favor by eliminating code duplication? Is the duplication actually what we think it is? So often, when I was starting a career as a developer, I learned what dry meant or what I thought it meant, and I followed all the rules, and I extracted all the duplication, and then my code fell apart and descended into what I called inheritance hell. And for anyone procedural, conditional hell is just as acceptable. So let's talk about what duplication really means. But I too have a story. Okay, so when I was a kid, these are not them, but I had two twin babysitters named Donna and Deanna. And they were the identical type of twin. And when I say identical, I mean those identical twins, so identical. I looked for the most identical twins I could on Google Images where I didn't have to pay or get a watermark on it. And they weren't identical enough, so I had to Photoshop it. Honestly, they looked the same, they dressed the same, hair, everything. Sometimes they would try to dress differently and come out of their bedrooms with the same outfit on. They took all the same classes in school, they played all the same sports, and when high school ended, they went to the same university to take the same degree. But then things changed. Deanna, obviously here, she loved it. So after the degree was done, she moved to a small town in Alberta. She got this teaching job. She fell in love with a rancher and settled into this quiet life. Donna hated it. So this is the first time in their lives where they're finally doing something different, and Donna decided to drop out of school. She moved away, first time she was ever away from her sister. She started working, but on the side she started boxing. And she really liked boxing. She was really good at it, and she actually excelled to compete internationally. Sorry, nationally. She was good, but okay. When that career ended, she opened a boxing studio and was really successful. Why am I telling you this story? So when I was young, I didn't understand the concepts of uniqueness or individuality, or that not only do we want to be our own person, but we straight up are our own person. And as time went on, Donna and Deanna, who commonly got mistaken for the same person, who I thought, aside from them having different bodies, were literally the same person, they became different people, and they led different lives. And I think our code does the same thing. You know, Deanna now lives on a ranch with some kids and some cows, and Donna is living a very intense lifestyle, and I don't think I've seen her without cornrows in 10 years or something. So the same thing happens with our code. When our code is young, we often have things that look the same. But we should be careful not to label them as the same because over time they could change. And I hope that we can explore how we can figure that out. So we're going to go through it in examples. And I've arranged the examples to tackle two directions of perceived duplication. So the first direction is perceived duplication that we can separate by drawing a vertical line. So in practice, this is things that exist in the same software layer that appear to be the same. And of course, I work at 7 shifts, so these are all going to be like restaurant scheduling app related examples. So in this example, it's our job to show the employees a list of their shifts on their dashboard, and to show the managers a list of all the shifts, of course, like sorted by time, whatever, on this manager schedule page. And this is what that UI is going to look like. Not a designer, sorry. So here we have identical UI. Of course, the employee dashboard looks like the manager schedule. The difference is what shows up in terms of data. So we write some code to render a shift. And I'm going to use Kotlin throughout this talk. If you've ever coded in Java, it's very similar. I'll try to explain anything that wouldn't make sense, but if there's any weird syntax, just feel free to ask and I can explain it. What's going on in this code is not really important. All that we should look at is that we set an image, we set a name, we set some dates, we set some times, and we set some restaurants. That's all that's important. What's more important is what's going to happen to the code. So we code this, and it works, and we ship it, but we don't, as developers, you ever get that question? They're like, well, what do you do when the app is done? Like, it's not done, right? Things change, right? Like, I was like, oh, it's done. Never needs to change. Of course it changes. So here's our first requirements change. So we introduced this concept of overtime, where your pay changes. And managers need to know about overtime on the schedule. But of course, employees don't need to know about overtime. So how do we do that? This is what it looks like. All we have to do is add this one little piece of text here that tells me how much overtime I'm going into for that person. And it's pretty easy. All we have to do is add a conditional that on the schedule, we render the overtime text, and for the employee, we just don't. Like, that's a pretty simple change. Nothing really derails. Of course, what happens when the app is done? It's not done. So there's another requirements change. Then we let users work at multiple restaurants within the same account. So it's a little redundant to show them their same profile picture over and over again in a list of their own shifts. So it'd be a little more beneficial if we could show them the restaurant logo. Also, didn't have to pay for it. Woo! Show them the restaurant logo instead of their profile image. And this is another easy change, right? Both these views have an image. We just have to populate a different image. So if we're on the schedule, we're going to fetch the user image. And if we're not on the schedule, we're going to fetch the restaurant image. We're not done. 2 more. After that, we quickly realized that showing their own name doesn't make sense either, right? Let's prioritize the date, because people actually probably want to know when they work. They don't need to be reminded of their own name. So let's move the date up for the employees. So we're going to put the date in that more noticeable text. I renamed what used to be called shift name to be shift title, because it's more generic now. And in the case of the schedule, we'll put their name. And in the case of the employee dashboard, we will put the date in the text and hide the date. And there's just one more, and then we're through this example. So this view over here is getting a little busy. So we've got 5 lines of vertical space taken up, and you can imagine in a list of all your employees' shifts, that's going to get pretty busy and pretty useless pretty quickly. So we have a design change where we are just going to move the date over here, and that makes it look better. It shrinks back to the original size, and again, we already have a date. We just need to move it. So let's change how we render it. If we're on the schedule, we're just going to parse out the date or the month, the day of the month, and the day of the week, and render it like that, and then get rid of the original date text. And then this one's unchanged. We didn't actually have to touch that. So those are 4 pretty easy, pretty manageable, pretty like realistic, right? Okay. Changes to our code. And what does it look like now? So here it is. What changed? First of all, it's bigger. It's maybe twice as large, which is partly because we added new features, right? We added that whole new overtime aspect, so the code's going to grow when you add something new. But the rest of the requirements change were actually just replacements of existing content. So those updates differed, though, per page. And now we have all these conditionals through. And remember that this talk is about dry and duplication versus separation. So by keeping all of this together, we had a goal of sharing this code because we have two shift views that were the same view, and they're still views for shifts. So this code is to render a shift, so why should it separate, right? It's shift view code, so it stays shift view code. But where do we end up? We tried to eliminate shared code by extracting duplication. And I'm going to call duplication all of the code inside or outside the conditionals. So overall, we only have 8 lines of duplicated code. So that means that the rest of the code, that is the conditionals and inside the conditionals, I'm going to call separation. So we have 25 lines of separation. And in an attempt to eliminate code duplication, we've actually outweighed code duplication 3-to-1 by separation. And there's one more thing that happened here. When you're working on a piece of code that's shared between different projects or different developers are working on it at the same time, you never want to make a change that's going to impact the other person. So you always err on the side of caution, right? So if we had done these projects separately on 2 separate views, we probably would have noticed that both of them removed this date. If I'd been working on a view and I got rid of a date and it showed my IDE shows me that it's no longer used, I probably would remove it. But now we have both cases accessing this and it's not going to show up as unused. So we've created tech debt. So this is where we are. In hindsight, of course, looking at this now, the separation is clear. But how are we supposed to know? That's probably the question. How are we supposed to know that eventually these two things that look the same are going to be different? We can talk about that, but I have one more example first. Okay. Of course, the other direction is horizontal. So we can separate perceived duplication by drawing a horizontal line through it. And this is going to be software in different layers that appears the same. In this example, we have a notification center in 7 shifts that employees can look at to track the status of their requests. And Alex talked a little bit about some of the features that we have in 7 shifts. So we are going to render a list of these 3 types: time off, availability, and shift bids. So you know what time off is. Availability is similar. It's like recurring availability. So maybe you have a night class on Wednesdays or something, and you can never work after 6 on Wednesdays. And shift bids, if somebody doesn't want to work a shift, they can offer it up. People bid on it. If you approve one bid, the rest are declined. So all notifications have a type in this API JSON payload. They have a start, an end, and a manager action. So you can see how these influence the way they get rendered over here. This has a very faint orange color on it. You can't really see it, but it shows it's unread. Really easy at a glance. And they all render the same information, just in slightly different ways. So I'm going to make a Kotlin class that I can actually use in my Android code. This is a very simple class. It just has properties here to basically map this response down to Kotlin. I'm using a library called JSON here. All I do is annotate the property with the JSON key, and based on the type, it parses the primitive to Kotlin. Save my life. Okay. So in Android, when we want to render a list, we have to use these things called adapters. And all it is a framework concept that lets you map a collection of data to a collection of UI elements. And under the hood, it takes care of like optimizing memory management for you. So what does our adapter look like? Here it is. It's pretty big. I've even hidden a couple of the functions down here. Again, the code's not important, but I think what the adapter does is. So first I give it a list of notifications. Of course, that's what we're rendering. And I type the adapter that it extends to be a notification view. And you're going to see that influence our overrides next. And all we have to do is tell it 2 things. So first we have to tell it how many items are in the list, which is how many notifications. And then we have to implement this function that, given a position, binds that notification to the view. So this is what it might look like. All of our notifications render the same data, but they do it in slightly different ways, right? One of them showed like a longer date string than the other. One of them didn't even show the end time. But they're all based on the same data. So we use a when statement, it's essentially a switch statement. So when the notification type is equal to time off request, bind time off, et cetera, all I have to do is pluck my notification and bind it to the view. So for example, time off might look like this, where I'm looking at the action and influencing the strings that I render. I render my, the top part, the content part, and the image is like some time off icon, whatever. The important part is that this is a little bit different than the other 2 types. So don't be overwhelmed. The code is not significant itself. It's more so like the fundamentals of what are about to happen to it. So this works well. We ship it, of course. We're not done. Things change. People hear that we have a notification center, and they want to add a new type of notifications. So we also have this concept called events, where employees need to know about things going on at a restaurant because it really impacts how your work could go that night. So we're going to add a new event type notification. And this is what an event notification looks like. It still has a red property, it still has a type, it's called event. Events start, events end, but events also have a name. And more importantly, events don't have a manager action. So this is almost the same as a notification, but it's slightly different. My adapter, if you remember, requires that I use a list of notifications. So of course, if I'm going to put an event notification in here, it has to be a notification. And of course, we're going to default to inheritance to do that. So let's create an abstract class called notification. Let's push all of the shared content up to notification. And then we just have two concrete classes, one for actionable notifications and one for event notifications that implement the different concrete details. What happens to the adapter? There are changes. It's not super significant. I have to expand my conditional a little bit. And what this additional conditional is doing is an additional when statement, but this time it's checking the type. So this is sort of like Java's instance of, where I can say when notification is the type actionable notification, then continue in here. And there's also something called smart casting at play, where after a successful check of the type, in the following block it is that type. So I can pass in actionable notifications into these functions, and I can pass in event notifications into these functions without additional casting. So it wasn't bad. We managed to keep up with the changes. But of course, there's another change. So marketing catches wind that we have an in-app notification center. And they want to use this to send out just general notifications to employees about general things. So they define this content structure that we need to send to employees. Still has a red, of course. You can see the orange here. Still has a type. This one's marketing. But now they want to be able to put in a custom image URL, they want to put in a title, and they want to be able to put in a description. So just showing some general content. Of course, our notification class is going to suffer a little bit. So brace yourselves as we go through this inheritance structure. Keep the abstract class called notification with the two shared properties. Add a time range notification just below that. That has the start and the end. Time range notification extends to actionable and event with their one different property, and then straight from notification we come to a concrete marketing notification. And now all of these are notifications and can render in our adapter. So our adapter, again, it doesn't suffer too much, and we can just add in a little bit more into our conditional and one more function for rendering that marketing announcement. So where did we end up? Why is the notification class so ugly? And why are there so many conditionals showing up in our adapter? We had this goal where notifications are notifications, but to render notifications from a list of notifications, we have to do a lot of work. I think the main mistake was that our API JSON had the data that we needed for the UI, so we called it a notification. The adapter requires a list of notifications, so we were forced to make all new types of notifications be notifications. And because we based the UI on the notification class, it suffered just as much as the data. So the result is that our notification class is not only difficult to change, but it's now constrained by the UI, and it's also constrained by the API requirements. So it's going to be influenced from both ways. We've also doubled our effort every time we need to add a notification. First, we have to adjust the notification class, which I cannot even imagine what would happen if we added a third type, or added a sixth type, sorry, or if we ended up in a case where a notification needs to share data from two of those superclasses, because we can't do multiple inheritance in Java or Kotlin. We also have to go back and update our adapter each time we get a new notification type. So we poured all this effort into unifying notifications so that notifications could be notifications and our adapter could render notifications. But the first thing that the adapter does is use 3 conditionals to split them all apart anyway. So did we really accomplish anything? It's also a little disheartening considering that all notifications share the same layout. All notifications have an image, all notifications have a title, and they all have a description. So by extracting the duplication too early and saying a notification was a notification, we might ask if we extracted the wrong thing. So I think it's time to review the definition of dry. When I learned dry, or like heard it, and then walked away, and then thought about it years later, this is what was in my mind. I don't know if I'm alone in this or not, but basically, dry pops into my mind every time I'm writing code and I have deja vu. So I never want to write the same code twice. It should never appear more than once. As soon as you write something more than once, extract it and use that. But this is the real definition of dry. Every piece of knowledge must have a single, unambiguous, authoritative representation within a system. The key part of this definition is this word, knowledge. Dry is not about code. Dry is about knowledge. Two things that look the same could be different things, as we saw in the first example. But also, two things that look different could be the same thing, right? Like just consider two different algorithms that have the same outputs. It's the same algorithm. You should probably just choose one that's a little more efficient and go with that. So back to our example. The notification class fell to pieces, and our UI definitely came along for the ride. And now we need to fix it. Or maybe we could go back in time and start all over. The adapter still wants a single typed list, and dropping that type restriction would just send us back into like casting everything, which is no better than what we had before. So is it possible to have a single typed list that handles all these different types of notifications? Yes, of course it is, because we look at the part that's duplicated, and what's duplicated is the knowledge about the UI. It's not the knowledge about the API. So let's revisit that example, and this is the view model that we want. Every notification shares an image, it shares a title, and it shares a description. I'm not going to delve deep back into that code. I'm just going to kind of abstract it to this diagram. So basically, let's have three different classes that represent notifications. You could try and combine these if you want. That still doesn't affect what's going on here. The DTOs that are just responsible for deserializing that JSON get mapped to a common view model. And this is what our adapter looks like. So of course, we've removed any kind of separation from the UI, so our adapter has just synced straight up and is very straightforward and very easy to maintain. But what about those requirements changes? When we add an event notification, of course, we have to add a DTO to handle it, and we have to update our mapper because the event has to map to a view model, but the view model is actually unchanged, and the notification adapter is unchanged, and we don't have to make any further modifications. Of course, the same goes for marketing, because we based our abstraction or our extraction on the knowledge of the API, so it's unaffected. Okay, so remember that just because two things happen to be the same right now, or happen to appear the same right now, it's not always going to be that way. Just like Don and Deanna could have been mistaken for the same person when they were younger, if you looked at them side by side right now, it would almost be difficult to call them twins. You might have code when it's young that appears to be the same or can be moved around, but chances are, if you think about the purpose of it, or you wait a while until it's developed a little bit more, they're going to divert over time. There's that old phrase that premature optimization is the root of all evil, and I think that applies to duplication as well. That you shouldn't be too hasty to extract that duplication, but you should make sure that you know what your code knows before you call it duplication. So don't repeat yourself, but exercise caution when you're extracting duplication, because I could tell you the same thing 1,000 times in 1,000 different ways, but it's always going to be the same thing. And I think that thing is knowledge. So extract knowledge, not code. Thanks.